and gentlemen, this RedGaming.com video, we're going to be discussing AMD's new and upcoming audio engine known as True Audio. To say that AMD have been on a roll of late is an understatement. Of course, they have not only secured APUs for the next generation consoles, they're working on Mantle, which for those of you who don't know, it's a low-level API for PCs which promises better performance, although of course developers really do need to support it. They are releasing a new range of graphics cards, and with those is going to be a dedicated programmable audio DSP, or audio device if you prefer. So this is actually going to be buried straight onto the GPU. So for those of you who are not too familiar with PC architecture, I'll give you a quick rundown. Traditionally, PCs, especially now, the CPU is very powerful. And so, a lot of the time, audio is handled primarily in software. In other words, there's no dedicated processors to deal with it. It's simply offloaded to the typical CPU through typically something like the AC97 codec. It works okay. Sound quality can be pretty damn good. It can have, of course, 5.1, 7.1 surround sound and whatever else. But it's also can be quite expensive on CPU time. So, of course, the next generation consoles give you the opportunity to start improving this. Now, back when Windows Vista was released, there were numerous changes made, not only to the way the desktop, for example, handles the graphics card usage. It handled a lot of acceleration when it came down to the GPU now. So, obviously, this allows transitionally into, say, Windows 7, you to do a lot of transparency effects and so on, so it's using your GPU rather than your CPU. But also, Microsoft made some significant changes to the way the audio stack functions also. Now, there were numerous changes that Microsoft made to the audio stack. For example, it automatically converts all streams to 32-bit floating point samples. It also does, for example, things such as feeding your sound card with the highest possible output streams that it can handle, and there's much more besides. Now, this comes from numerous reasons. Typically, sound cards, especially the cheaper lower end ones, it was different for like the high end creative sound blaster types, but typically there were issues with crappy sound drivers. And also you had issues with low-end audio chips as well. And so Microsoft decided, you know what, we're going to start implementing a lot of the functionality in software APIs. So you got this trade-off. You always get trade-offs, as I've always said. But you improve the audio stack stability. In other words, less chance for crashing, less chance of popping audio, and so on and so forth. Conversely, you also prop up the basic standard features of the audio. So in other words, that's great. However, you also have a few other issues. One of them is it also cut off the hardware acceleration of Direct Sound 3D, which of course was back then the 3D audio API. Now, if you're thinking to yourself, that sounds a bit familiar, audio DSPs, I'm sure I recognise that name from somewhere. Well, of course, not only are they integrated into the next generation consoles, for example, we know the Xbox One has a ridiculously powerful one, but also they were around even back in the late 90s. For example, with a lot of the Creative Lab stuff sported them. So Windows 8 has come out, and there have been numerous changes. Of course, Windows 8, one of the big ones is the new versions of DirectX 11.2 support and so on. But for gamers, it's also going to, and audio lovers, it's also going to be changing the way, or has been changing the way that audio is calculated and used as well. So no one's really attempted this since, 2005, 2006. And it's a simple reason because of the way the audio changes have affected the operating system. This is a simple case in point that obviously the hardware can only do what the software tells it to. This is, of course, mirrors and everything. From consoles, the first generation of games are obviously always the worst in terms of aesthetics and frame rate and everything else, to operating systems. In other words, you can't utilize hardware if the APIs just don't allow you to, which is one of the reasons, of course, AMD are working on Mantle for the graphics side of things. So, back when I was really starting to get into PC gaming. I think I've mentioned this before, but it was around, the late 90s, really. I was kind of just getting old enough to understand how everything worked, and I was loving it. I had like a reasonable PC for the time and much more besides. So I was looking at the time at various articles in magazines, and there were so many different instances of audio and audio improvements, and it was becoming like every couple of months there was a huge jump in audio performance, and we were going from like very simple sounds to extremely expensive 3D, and we're talking about for the time. Case in point, back in the day when I was first playing, there was a little title that you guys may be familiar with known as Half-Life. Now, Half-Life, there was a section in it, I've mentioned this once or twice, but there was a section in the game basically where you're about to activate the rocket engine. I'm not going to spoil it, but basically there's a lot of noise in that section, and a lot of it is actually positional audio as well. Conversely, even if you had a faster CPU, you'd notice a significant FPS drop on that part if your audio was, well, software related. In other words, the CPU was processing it, because the software was basically handling a lot of audio. So after a while, I decided, you know what, bugger this, and I bought myself a cheap but reasonable sound card. I believe it was like a Creative Blaster one. I have no idea of the exact number. I think it might have been a 128 or something. Regardless, anyway, when you put that sucker in, you automatically offloaded a huge amount of the work from the CPU, and up went the frames per second as a direct, result of this. Now, audio calculations aren't that expensive, so two-channel stuff, not that bad. 3D stuff, such as, stuff that's already pre-computed, in other words, it doesn't really need to work about, it doesn't really need to calculate much, it's already, the CPU already knows it's in the background, for example. Or, for example, panning, where, of course, sound obviously travels, or whatever else. It's not that expensive. I mean, just for example, this is a really bad example, but, open up Media Player while sound's playing. MP3 playing now is nowhere near as expensive as it used to be. But that isn't to say that all stuff is cheap. Things such as, for example, 3D transformations, reverb, and much more are actually pretty damn expensive, particularly when we're dealing with something like a 5.1 or 7.1 surround sound system. You can imagine how, in computer terms, it becomes expensive. In other words, the cost of running it is high on that particular CPU. So AMD have noticed the games developers obviously have started to reduce the effects, and the audio march, if you will, started to slow down. Progress started to reduce a little bit. Despite the fact that audio quality is extremely high, games developers haven't really been able to utilize the immersion. So, one may automatically notice, well, this leads you into a problem. Firstly, not all of the next generation Radeons, for example, carry this new audio DSP. The second one is that let's assume that you've got the hardware, let's assume that you have the software support to do it. Then you need to convince Bob, the developer, to actually develop for it, and this is a really big issue. This was one of the things that I've been stating before when it came to the Voodoo API, when I was talking about Mantle. One of the reasons that 3dfx had an advantage over the competitors is because they were kind of at the front of the 3D graphics march back in the day, and as such, Glide, which was their own API, was very, very well thought of, and so a lot of developers just included it as a standard, especially because back then there was no real clear winner between OpenGL, DirectX, and everything else. It's kind of a free-for-all. So when you think about it, it was kind of a natural progression, but eventually the developers decided, you know what, bugger this, we can't keep developing games for multiple platforms or multiple APIs, and this has been the same thing, for example, with Creative. Their own DSPs are very powerful, but back in the day, you would actually have options based upon the graphics card, and then of course that would tell the game, well, okay, this is what you need to do, and this is what you need to support. Unfortunately, it's no longer that simple. Games developers have to rely on a plethora of different hardware. So, there needs to be some level of consistency. Now, obviously, we know that the next generation consoles are going to have very powerful audio processors. We don't really know that much about the PlayStation 4s. We do know the Xbox One has a very powerful audio DSP in it. We don't know as much on the PS4. But AMD is starting to forge relationships. They are that company that are trying to get in everyone's pockets. And I don't mean that in a negative way, but they're trying to become best friends with as many people as possible. For example, they're working currently with a company known as Gen Audio, that is GEN Audio, and they have created an audio engine by the name of, or should I say they are utilizing audio engines by the name of True Audio DSP. So what they're going to do is they're going to release middleware plugins which are going to help to push forward the progress and start to act as kind of an intermediary. So just how Battlefield 4, DICE, of course, have pledged that mid to late December, we're going to be getting an update, or AMD owners are going to be getting an update to utilize Mantle. You've also had EDIOS. Now, EDIOS are saying that the next generation Thief game, the one that's coming up, is going to support the audio engines. Now, there are numerous benefits for this. Now, the reason they're actually putting it on the GPU and having developers use it is that way, what's going to pretty much happen is that developers can use it, they can have the hardware process the audio, then it will be passed back to the sound card. So in other words, it'll be very similar to, say, how 3D cards used to work in the day, but instead of being a pass-through, it would then pass the data back. So it would be like sound. So the CPU handles it, gives it to X, then it's calculated, and it's given back to Y, if that makes any sense at all. There's great news about this. This means that you can output it to pretty much whatever you want. So, of course, that will mean things such as HDMI, as you'd expect, speakers, for example, headphones, of course. The issue, of course, with all of this is that they're going to need to support, and by they, I mean the developers, the games developers, True Audio. So, it's not really a march forward. That's the key point. This is not some new incredible technology that's like, going to revolutionize PC audio. This is actually stopping the stall. This is stopping the engine from just simply not going forward anymore. It's kind of like, we've been stuck on this point for a long time. And some would argue we've actually moved back some, because now less and less dedicated audio chips are being shipped with PCs. The sales are actually, I would say, dwindling. Like back in the day, a lot of the gamers I knew, a lot of PC gamers bought a dedicated audio chip, but now it's not really been a big deal. Games haven't really supported it, and so you kind of get into this thing, well, you know what, it's not being supported, why should I drop X on this product? Bollocks, I'm just going to stick with the basic chip, the CPU is fast enough to handle it, blah, blah, blah. And that's not really a good mentality, because it obviously stalls progress. So all AMD are trying to do is facilitate a method to enable better utilization of this. Now, automatically you're going to get people who point out that this is just going to free up CPU resources, but a very high-end CPU is going to be able to handle it anyway, and that's true. But in theory, you're going to be able to get crisper audio. It's going to free up CPU resources. Plus, as well, from my point of view, I don't necessarily know at this point if it's going to be worth saying, okay, well, I need to buy this graphics card for this. However, I am hoping that there are at least some advances caused by this, and that's the key. It's not necessarily that a piece of technology is ever implemented exactly how you expect it to be. That's the key. I mean, let's use an example. Gears with the physics cards, the dedicated physics cards. They had this vision of them being like the new addition to a PC, and they weren't. They were just basically acquired by NVIDIA. Their technology was then implemented into the cards, and now of course you've got physics, and a lot of the ideas they had kind of sparked and helped to push forward the SIMD architecture of modern day GPUs in that respect. It helped to say, okay, well, we need this for general purpose computing, and so, well, there was multiple reasons behind that. I mean, one of them was simply that NVIDIA noticed that, well, you know what, guys, we noticed that certain parts of the GPU just aren't being utilized, so it's much better to actually have a SIMD architecture where you have multiple streaming processors which can be utilized for whatever. So in other words, it can be used for either texturing or it can be used to create a polygon. So in other words, it's much smarter utilization. So I'm not saying that this is exactly a newfangled piece of technology. I'm not saying it's going to revolutionize PC gaming. But from the perspective of games developers, it's certainly going to give them some food for thought, and I do hope that we see some improvements on the audio side of things for the audio levels out there. Anyway, all of that said, hopefully you've enjoyed the video. I'm going to get going, so take care of yourselves and bye for now.